Okay, good morning, afternoon, or night, whenever you're watching this. If you are here, it is because we have made it to trigonomic ratios in geometry. Okay, so what are trigonomic ratios? Right here, I'm going to have you write down these definitions, right? Trigonomic ratio is a ratio of two sides of a triangle. The sine and cosine involve the hypotenuse of the triangle. Now, if we think back to last week when we went over the tangent, and remember how I made a point of saying that the hypotenuse is the longest or the largest side of the triangle, and that you didn't have to worry about it because we weren't going to use it? Well, that's because we don't use it for the tangent. We do, however, use it this week to figure out what sine and cosine are, and this is what you're going to be doing today. That right there, figuring out these two, sine and cosine. Again, these are just the definitions. Go ahead and write them down. Make sure they're in your notes so they can be ready to be turned in. Sine is just a trigonomic function that is equal to the ratio of the side opposite to a given angle in a right triangle to the hypotenuse. Cosine is a trigonomic function that is equal to the ratio of the side adjacent to the acute angle in a right angled triangle to the hypotenuse. Now, that's a really, really complicated way of just saying sine is equal to opposite over the hypotenuse, and cosine is equal to adjacent side divided by the hypotenuse. Right? And this will all become clear in the next slide because I'm going to break all that down. But for now, just go ahead and write the definitions. Okay, something else that you need to know is this term. Now, if you were in my class last quarter, we went over complementary angles. Complementary angles are two angles that always add up and equal 90 degrees. They equal 90 degrees every single time, and this is really important, right? So what do I mean by that? Well, down here, right, if you look, I have an example of a right triangle. A right triangle, if you remember from last week, is just a triangle that has at least one 90-degree angle, right? Let's label this A, B, and C, right? And the 90-degree angle is there, which means that this is a right triangle. Okay. Now, what I mean by that is what I'm doing here is I'm introducing a couple other vocabulary words. Kind of, if you've never seen this before, just make sure to write them down. If you know what these are because you were in my class last quarter, then just a refresher. You can go in and you can feel free to skip this part. Acute angles are the other angles. They're the angles that are smaller. The actual word acute is referring to an angle that is less than 90 degrees. Also, I need you to remember that a right triangle is equal to 180 degrees total. Why is this important? Well, remember, the condition for a right triangle is that it has to have one angle that's 90 degrees. And all three angles have to add up to equal 180 degrees. Now we know that 90 plus 90 gives us 180, which means that the other two angles, the other two acute angles, both have to be less than 90 degrees. And when you add them up, they have to equal 90 degrees. In other words, they're complementary. So if I were to add up measure angle A plus measure angle B, or the acute angles together, I'm always going to get 90 degrees, right? And we're going to go over a shortcut with this. This is going to factor into a shortcut I'm going to show you for the calculations later on in the video. But just remember that this is important, right? That's why I made a note up there, and that's why I bothered to do this here. Okay, just keep that in mind. Write it down in your notes. Let's move on. This next section in your notes, you can write it as is a type 1 problem, right? And the type 1 problem is just, what's the difference between sine ratio and cosine ratio? In this case, I need you to understand how to identify when to use sine and when to use cosine, because there are going to be different situations where you can only use one or the other, or you're forced to use both, depending on if it's like a word problem or whatever. And you need to understand that for this week, the first thing you should always do when you're doing any of the problems I give you this week is just to remember, okay, am I going to use sine or am I going to use cos? I have to use one of these two, okay? Tangent was last week, so we're not going to deal with tangent this week, but just know that tangent is another option as well for the harder problems. Anyways, so what is a sine ratio and what is a cosine ratio, right? We have the exact same triangle here, right, as we do here. And sine, I have the formula that says opposite over hypotenuse. Let's go ahead and focus on the bottom angle right here, angle B, right? Let's pretend that we have an angle here. Let's say we have like, this is, I don't know, 30 degrees or whatever, right? This is 30 degrees. Okay. Sorry, that's supposed to be a degree. Sine is 30 right there. This is 30. Okay, so what does this mean? Well, sine, in order, if I wanted to just find out what the sine ratio is of this triangle, right, I need to focus on an angle. And usually I would focus on whatever angle I have the degree for. In this case, I'm going to circle the angle that I'm going to focus on. I would highly suggest that you guys do this. I did this last week as well, all right? But make sure you circle the angle that they, notice I don't have a degree for angle A, but I do have a degree for angle B, which means that the problem is intentionally telling me that I need to focus or I need to start with angle B. So I'm really looking for, in this case, sine of angle B, because I actually have a degree for there, and I'm going to need that. Also, opposite over hypotenuse, right? So the opposite of this angle, I need to look at the side that's opposite to it. It's 4. It's AC, right? So right here, I would write sine of measure angle B equals opposite, which is 4, over hypotenuse, which is 5. Now, I know I just said you need to focus on the angles where they give you an angles, but if they're just asking for like a ratio, right? If I were to just ask you, hey, what's the sine of angle B? It's 4 over 5. If I were to ask you, hey, what's the sine of measure angle A? And you're like, well, I don't have a degree for that. Well, it's okay. You don't need one. Just go ahead and tell me what it is. Well, in this case, if I were to focus on A instead, opposite would change. Opposite would be 3, and hypotenuse would stay the same. So for sine of A, of measure angle A, it would actually be 3 over 5. Right? So if you notice something, a change from last week, you just had to flip the ratio, right? This time you can't do that. You have to pay attention to what they're asking you, right? If they're asking you for sine of B, make sure you figure out what sine of B is. If they ask you what sine of A is, make sure you do what sine of A is, because the issue with this is when we get to the more complicated problems, this is the easy part, just identifying what the ratio is. If, however, you misread the fraction and you use the wrong fraction in the beginning, your entire problem will be wrong. So just understand that it's not that big a deal, but just try not to skip over this part, because it can lead to you getting the wrong answer even if you get everything else right. Okay, so that's sine, all right? What about cosine? Well, if we turn here, if I ask for what is the cosine of angle B, right? I would start with cos of angle B is equal to adjacent. Now, adjacent, remember, is the angle or the side that's connected to the angle that I'm focused on. In this case, I'm focused on angle B. The side adjacent to it is 3, and the hypotenuse is just 5, right? And what if I wanted to know cos of angle A? Well, my new focus would be on angle A, and opposite to angle A, adjacent to angle A, because remember, we're doing cosine. The adjacent would be 4 this time, because AC is connected to angle A. So that would be 4, and the hypotenuse doesn't change, right? They're both going to use the hypotenuse. 3 over 5, 4 over 5. If you notice, cos of A and sine of A, right? They're opposites. Also, if you notice, sine of B is the exact same thing as cos of A. Cos of B is the exact same thing as sine of A. That's on purpose. And that has to do with the complementary relationship between those two angles. If you don't remember what complementary means, that was this situation. We'll get into that later. Why don't we move on, right? Now, oops. Okay, problem type 2. That was the other kind was problem type 1. This is the second type of problem that you're going to find, right? This is the second type of example. Finding the missing side length using sine and cosine ratios, right? So we have a background information. A 12-foot ramp is installed alongside some steps to provide wheelchair access to the library. The ramp makes an angle of 11 degrees with the ground. Okay, that's the background information. Cool, we have a ramp, and we need to figure out how tall the ramp is, right? Okay, problem. Find each dimension to the nearest foot. Okay, so they want us to find out how tall it is and how long it is. I happen to know the hypotenuse, which is the actual ramp, but they want to know the legs of that triangle. Okay, interpretation. Okay, so we have a ramp, which means we have a right triangle. Let's draw one if it's not provided. If they ever don't provide a triangle, I would strongly recommend you draw one to the best of your ability. They said that the ramp itself is 12 feet, meaning that the ramp is the hypotenuse, which is why I put 12 right here. It's the longest side. Since it makes an angle with the ground, right? The ramp, you need to find the part of the triangle where the ramp touches the ground, and that's this part. That's 11 degrees. It makes an angle of 11 degrees. So that's where I put the 11 right there. Okay, after drawing the circle with the angle, the degree as your focus, determine if you need to use the sine or the cosine. Now, here's the key part to this problem. I notice I haven't even started the problem yet. I haven't started with the formulas. I haven't started with anything. All I've done so far is draw the triangle, label everything, and figure out what they want. They want to know what BC is, which is the wall. Well, what happened? Okay. Okay, that threw me off. Okay. They want to know what X is, and they want to know what Y is, right? Given what we know that we're focused on angle A, which is 11 degrees. We know that the opposite side is going to be X. And we know that sine is opposite over hypotenuse. In this problem, I want you to note that you're going to have to use sine and cosine. You're going to have to use sine to figure out what X is, and you're going to have to use cosine to figure out what Y is, okay? And the only reason it shakes out that way is because we're focused on only one angle. We're focused only on angle A. Opposite to angle A is X, and we know the hypotenuse, which means that in order to figure out what X is, we need to use sine because sine is opposite over hypotenuse. However, starting from the same angle, right? If we want to figure out what Y is, well, Y is my adjacent, right? X is my opposite. So if I want to figure out what Y is, I have to use adjacent divided by the hypotenuse, which happens to be cos. So depending on which one you want to do first, you can do either one. They're both going to be solved in the very similar way. Now I'm going to use the formula. I'm going to focus on sine first. I'm going to focus on X first. So I'm right here, right? Sine of angle A is equal to opposite over hypotenuse. Now that I know that I'm using sine, I'm going to use the formula for sine. Again, opposite over hypotenuse. I wrote it down. Cool. That was step 1. Check. All right, step 2. Sine, well, I have to substitute what you know, right? So what I know is that angle A is 11 degrees. So I'm going to put 11 inside of parentheses, sine of 11, right? That's this thing. Sine of 11 is equal to, and then I'm going to replace opposite. Opposite is, I don't know what opposite is. So I'm going to put an X there. X divided by my hypotenuse. I know how the hypotenuse is 12, so I'm going to put 12. Okay, so I substituted what I know. Okay, so now I'm in a situation where I have a denominator that's a 12, and I need to get rid of that denominator because I want X to be by itself. In other words, X is being divided by 12, and I want to stop that from happening. I want to do the opposite. I want to do inverse operations. In order to get rid of the division, I have to do the opposite, which means I have to multiply both sides by 12, because if you are dividing something by 12 and then you multiply it by 12, you end up getting whatever you started with in the beginning. So I multiply both sides because, remember, what I do to one side of the equation, I have to do to the other side of the equation. Otherwise, they won't be equal. Now, I multiply it by 12 over 1, right? So the 12s cancel out, right? I'm down here. And I'm left with just x on the right side of the equal sign. On the left side of the equal sign, however, I have a situation where I have 12 in parentheses times sine 11. If you're wondering where I got sine 11 from, I opened up my calculator. You moved it to the side. I did whatever I needed to do. If you're using Android, if you're using an Apple, both of them most likely you'll have to put it to the side, and you'll have more options. You have to look for the option that says sine, and if you're using Android, you're gonna press the button that says sine, and then this should pop up, and then you're gonna type in 11. You're gonna close it, and then you're gonna put equal, and it'll give you the answer. In this case, I have 0.19. If you're using an Apple calculator, I really don't like those. But if you are using an Apple calculator, right, you're gonna have to put the number first. You're gonna have to put 11, and then you're gonna have to look for the button that says sine, and then you're gonna have to press sine, and then it'll give you the same number. But for whatever reason, it just won't show. I haven't figured out if it'll let you show it by doing another symbol. I don't have Apple phone, so I don't know how to really use that calculator. That's my best advice if you're using one of those. If you're using the Desmos calculator, just click on the sign button and then put 11, and it'll work. Right? The Desmos calculator is the calculator I have linked in the Google Classroom. Look for scientific calculator link. Okay. Anyways, I have 0.19. It was actually 0.18 something, and I ended up rounding it up because I didn't want to put all the decimals. So 0.19 times 12 gives me approximately 2.29, which gives me my x, which means that the height of this ramp is 2.29 feet. However, we're going to want to round. I don't want that many decimal points. Because we're dealing with real world numbers, it's a good idea to round to the nearest whole number, but in this case, it would round down to 2. And since we're dealing with a ramp, you actually need to make sure you have more than necessary. So I would round it to the 10th place, right? So the 2 looks to the 9, and the 9, since the 9 is a 5 or higher, it pushes the 2 up to a 3, 2.3, right? This is my final rounded answer. Personally, I would accept either answer. But in the real world, you want to make sure, if you're doing like a ramp, you want to make sure that the height is covered to the best of the degree. And you'll see later on why that actually makes a lot of sense and why that matters. But for now, just know round to the nearest 10th, the first decimal point, or the second decimal point. All right, cool. So I know the height. I'm done, right? Well, no. Remember, they asked for each dimension. That means that they not only do they want to know what x is, they want to know what y is. They want to know uh the floor, right? They want to know BA, the segment BA. They want to know what y is. Those all represent the same number. So I'm gonna move on to this part, right? To the coast. Since we're focused on A and I want to know what y is adjacent to angle A, which means that if I'm going to use adjacent formula, that's part of the cos formula, which is why I have to use cos. Why does it matter which one I use? Well, cos and sine are complementary, which means that one completes the other. So it actually matters a great deal because it's going to give you the wrong answer if you try to use sine again. Anyways, if you notice, we have cos is equal to 11, right? We substituted what we know. Cool, cool. All right, now we got to use inverse operations, right? So we got to get rid of that denominator, that 12, right? We're going to multiply both sides. This is looking very similar to what I just did over there. And that's because the steps are exactly the same. The only thing that changed was I'm using cos instead of sine. However, because I use cos of 11, if you notice, I have 0.98. And on the other one, I have 0.19, right? If you were to add those together, you get really close to 1, and that's on purpose. Anyways, 0.98 times 12 gives us 11.78, which equals to my, oh, I have x here, sorry. This is supposed to be a y. This is a y for all of them. Yeah, this is y. This is y. So 11.78, or I'm going to round, right? And this makes my final answer 11.8. Again, I would accept either answer, but in the real world, some answers are better than others, especially depending on the context. So, right, the floor of this ramp has to be at least 11.8 feet. The height has to be at least 2.3 feet in order for the ramp to have an 11-degree decline and be exactly 12 feet. The ramp only, right? Okay, that was a lot. But there is another issue here. This is similar to what you did last week. And I want to make a clarification because last week I showed you guys how to do this, but I didn't show you guys what to do if for whatever reason you have a variable on the bottom. Like right now, I know this is what I have here, but what if you had a situation where you had 12 and you had the variable on the bottom? I saw a lot of you guys do this, right? Last week, and I see this in a lot of you guys' work. I didn't take any points. This is actually wrong. I didn't take off any points. You guys got your full points for that because I realized I didn't go over that in the thing, and you guys did your best, which I appreciate, by the way. However, you can't actually do this because what's going on is this causes all kinds of problems. You can't do this because that leaves you with a 1y, and that is not the same as just a regular y. Okay, so then what are you supposed to do? Well, find the side length continued, right? I'm gonna create a problem in which you would have your variable on the bottom of your denominator. Okay, this is a follow up to the previous problem. All right, background. Suppose you had your ramp, right, and new regulations came out from the state that said the maximum angle of the ramp for wheelchairs has to be 8 degrees. Problem: your last ramp was 11 degrees, so you got to tear down that ramp and you got to build a new one. This means that you may have to make a new ramp and it'll have to have new dimensions, which means if you mess with the degree, all your dimensions will change. All right. So now you're trying to make this new ramp. The height isn't going to change. The height has to stay the same. You just have to expand it so that it's longer, right? That's the problem. Interpretation. We'll draw a new triangle and label it with what we know. However, this is different because we're looking for the hypotenuse this time. We want to know how long the ramp itself is going to be because we don't know how long it is. We just know how high it has to be, right? Okay, so we have it there. And we're going to approach this the same way that we approached the last one. We have sine of A because we know what the degree is. We know the opposite, and we actually know what the height is. It's 2.3. And if you're wondering where I got 2.3 from, it was this answer right here. You guys remember? Okay, cool. That's where we got the 2.3 from. Remember, because the only thing that's changing is the floor and the hypotenuse, but the height doesn't have to change. The angle degree changes, and the angle, right, is made up of the floor and the ramp, which is why those dimensions have to change, but not the height. So sine of A is equal to opposite over hypotenuse. Cool, I used the formula. All right, sine of 8 degrees this time is equal to 2.3 over x. All right, so we have a variable in the denominator. What are we going to do? Okay, so we're going to have to solve this in a different way. We have to get rid of the variable this time because the goal here is to get rid of the denominator. We don't want a fraction there. And just because we don't know what x is yet doesn't mean we can't move it around. If we multiply by x over 1, we have an x on the top of the fraction and we have an x on the bottom of the fraction. We're also going to have to multiply x by the other side, right? And really all it is that the 0.14, by the way, I got 0.14 because I put sine of 8 in my calculator and it gave me 0.14 something, whatever. Anyways, 0.14 times x, I just kind of put them together. I just put the 0.14 first. I put the x next to it. 0.14 is multiplying by the x. The x's on this side cancel out. So I actually moved the x over from the right side of the equation to the left side of the equation doing this. And I'm left with 0.14x or 0.14 times x is equal to 2.3. In which case, now I have to use what we call inverse operations. Again, both of these steps are inverse operations, but they're just different operations that I had to invert. In this case, I had to multiply by my variable, by my x, multiply both sides, right? And I ended up with a rearrangement of my formula. And then inverse operations, well, 0.14, I need that x to be by itself. So in order to get rid of the multiplication, I had to divide both sides by 0.14. So this time I had to divide by 0.14. Okay, cool. So when I divided, they canceled out. My x was left there. It's 2.3 divided by 0.14. You're going to get something interesting here. When you divide by a fraction, like a decimal, like a 0 point something, the actual math says that you're multiplying. I know that sounds confusing. I won't get into it today. But remind me, I have to get into that at some point because it is interesting. You end up with a bigger number. You end up with a massive number that you probably wouldn't have expected. The ramp at minimum, at least, needs to be 16.43 feet long, right? But given that it's a ramp and given that, you know, when you're dealing with cement, that's kind of hard, it's much easier to say, well, we're going to round it and we're going to make sure that we have uh, enough height, right? That just means that that's the absolute minimum. 16.43 would make a perfect 8 degree, which is the new maximum amount. But if you want the ramp to be to fit the regulations, you just need, with the height of 2.3, right? You just need the ramp to be anywhere bigger than 16.43, right? In order to maintain a degree of 8 or less. Right. So basically my answer is just 16.43 or 16.5 in the real world because you want to have a little extra breathing room when you're designing these things. All right. All right. That was crazy. Okay. We're almost done. Kind of, sort of. Don't hate me. Now, finding the missing angle measure using sine and cosine. This is going to go faster. Remember last week when you had to use the inverse of tangent to figure out the angle? This is going to be the same thing, but you have to use sine or cosine. And like with sine and like I said before, the first thing you always want to do is make sure that you know which one you're using. You're either using sine or you're either using cos. Now, let's look at the problem. The problem, find the accurate measures in the triangle, the acute measure, sorry, in triangle PQR to the nearest degree. Now, there's that word again. There's acute. Now, if we remember from the vocabulary in the beginning, we said the acute means angles that are less than 90 degrees, which means that they want to know this angle and this angle. Interpretation. They want us to find measure angles P and Q since those are acute. However, since they are finding missing angles, we need to use inverse cos and inverse sine to figure this out. All right. So let's start with sine, right? Sine of R. Why would I start there? Well, take a look at the dimensions that we have. We know what QP is, right? Given that we know that side QP is 7, and that side is opposite to measure angle R, right? 7 is opposite to measure angle R. We know we can use the hypotenuse, right, which is 13. We have enough information to solve for angle R. I'm just choosing to start with sine. You could, in theory, start with cos, and you'd get the same result, but you just need to make sure your ratios are correct. So in this case, I want to figure out what R is first. So sine of R is equal to opposite over hypotenuse, right? So that's the formula. Cool. Now, sine of R is equal to the opposite. Opposite of R is 7, which is my numerator. And my denominator is my hypotenuse, which is 13. Cool. I substituted. Is that my answer? I'm done? Nope. Nope. I am looking for the angle. And so far, I just have a ratio. That's not what I'm looking for, which means I'm going to have to kind of use the ratio and go backwards again. Remember, inverse means basically the reverse. It means go backwards in this context. So I have to use sine of -1. In parentheses, 7 divided by 13 is equal to my measure angle R. I have to rearrange so I can use the inverse ratio. Okay, so now that it looks like this, now that I've set everything up, I can actually put this in the calculator, and the calculator will do the work. I have this weird step. It's called translate for the calculator. The reason I wrote that is because that's going to be really important for next week. But translate for the calculator, pretty much what I'm trying to tell you is that the calculator is a machine. It doesn't understand what you're trying to do here. It is given a task, and it does the task for you, but it doesn't understand what it just did. You are the intelligent one. You are the person that can make sense of the math problem. The calculator can't do that. And if you don't set this up properly, the calculator will not give you the right answer because the calculator is a machine and you can't think. You, however, think, and you are intelligent, which is why I want to see every single one of these steps, and I want to see you set it up correctly so that when you put it into the calculator spits out the correct answer. All right? Okay, so here, you're going to want to look for the sine, the inverse sine on your calculator functions. Sine of -1, parentheses, make sure to put the parentheses if it's not already included when you press the button. 7, and you're going to have to physically press the divide button by 13. So putting it in this way, you can put it exactly like this into an Android calculator, and it should spit out this number. And I cut it off because, the number goes on for a while. But it gave me this number, 32.58, and that's technically the right answer. However, I want you guys to do one more step after that. I want you guys to round to the nearest whole degree, because when we're dealing with triangles and degrees, we usually want to round to the nearest degree. I don't want 32.58. I want the full degree. The 2 looks to the 5, and the 5, since it's 5 or higher, pushes the 2 up. Measure angle R is 33. Now, this is really important because of what I'm going to explain later. Okay, so what about, cool. So I know that measure angle R now is 33 degrees. So what? Well, there's a shortcut to figure out what the other angle is, but I'll explain that later. Why don't we figure out what it is based off of cos, right? So cos of measure angle P is adjacent over hypotenuse. And we're choosing to use cos of P because the only piece of it, we don't know what QR is. We don't know what opposite of measure angle P is, so we can't use sine. We do, however, have QP, which is adjacent. And since it's adjacent, we have to use cos. So notice it's the same ratio. Look, we have 7/13 and we had 7/13 here, but we get different things because we're using different functions, okay? So we're using different trigonomic functions, sorry. Now, cos of P is equal to 7/13. We're going to want to use the inverse cos, right? So we're going to want to use cos of -1, parentheses 7 divided by 13 is equal to measure angle P. Again, I'm translating for the calculator. This will be important next week, but you should start learning how to do it now. Cos of -1 divided by, parentheses, open parentheses, 7 divided by 13, close parentheses, equals, and it should spit out roughly something that says 57.13 or something, which I ended up rounding down to 57. Okay, so how do I know if I'm right? How do I know if I even did it correctly? Well, remember that I said that measure angle, the acute angles are complementary. If you don't remember, complementary just means that they add up to equal 90 degrees. Well, in theory, if you figured out what both of the angles are, we should be able to take this number and add them together. And if they give me 90, I'm correct. Well, let's find out. Measure angle R plus measure angle P is equal to 90. That's where this came from. 33 plus 57 equals 90. Hey, it worked. Now, for some of you, you might have already realized that that is a shortcut. You don't really need to do both of those if you didn't want to. Please do them because I want you to practice. But this is the fundamental difference between you and a calculator. The calculator would have to get the inputs of both of these to get both of these answers. You, as a person that can critically think, don't need to, and you can use a shortcut that the calculator cannot. All right, here's what the shortcut is. let's say that, let's reverse course, right? We just figured out that the R is 33 degrees, right? We did the sine, we still did the sine, we have to do at least one of them, and we found out that R is 33. We know that R and P are complementary, so we know that one of those two angles, if we know one of these two angles, we know both of them, because all we really have to do is subtract one of the angles from 90 to get the other missing angle, because they're complementary. So I set up my equation. Measure angle R plus measure angle P equals 90. I know that is 33 plus measure angle P is equal to 90. Subtract 33 from both sides. Measure angle P is, hey, look at that. I get 57 again. And I did it in half the time. And I didn't even need to use a calculator. And that's the difference, right? Because a calculator could figure all this out, I guess, if you told it, if you set up the problem for it, and you set up both problems, and you told it what to do, and then all it did was wrote them down for you and did the actual math for you. Or you can get an understanding of this, think critically, and figure out, if you figure out one, you can use the properties to shortcut another one, and you don't even need the calculator. The calculator can't do that. Only you can. All right? All right, then. Almost done, I swear. I'm sorry these videos take forever, but normally if I were to be in class, you would have 4 lectures of 15 minutes long each, for the one for each day of the week that you'd be in school. So sorry, this is at least going to be like 45 minutes, but come back to it, take breaks if you need to. Make sure you just get all this in your notes. This is you might have heard this before, SOHCAHTOA, and it's a mnemonic device that's used to remember all these formulas. Personally, I don't like SOHCAHTOA. I don't like the moniker. I think it sounds weird, and it's never once helped me remember. However, literally everyone else that's not me likes SOHCAHTOA, so I feel obliged to show you what it is, and then you can decide if you want to use it or not. Okay, so SOHCAHTOA is basically it's just abbreviations. It's just so you can remember. SOHCAHTOA, each one of those letters stands for something, and I have the letters here on the side. These tell you what to, that keeps happening. Okay. This tells you what this is. So if you're wondering, okay, what was the formula for sine again? Okay, SOHCAHTOA, right? SOH. Sine is equal to opposite over hypotenuse. SOH. SOH. Right? And then you can draw a triangle and you can do the opposite over hypotenuse, and it all kind of works together. Right? That's what it stands for. Right? So if you're like, but what if I need cos? Okay. So CAH stands for cosine, adjacent, and hypotenuse, in that order. Cosine is equal to adjacent over hypotenuse, right? Because C is cos, A is adjacent, and H is hypotenuse, right? And then TOA, right? This is from last week, tangent. It's I would imagine the H is silent, but whatever. Anyways, TOA, right? Uh, so did I? Oh, wait, no, I did it wrong. This is why I hate this. Right, TOA. Okay, it's an A. Okay, so tangent is equal to opposite over adjacent, right? So that's it. If you're having trouble remembering this, try it out. SOHCAHTOA, right? Like I said, if it helps you, by all means, do whatever it is that's going to help you remember. Just because I don't like it doesn't mean you shouldn't. By all means, do whatever you need to do. But I really don't like it. Anyways, so moving on. If you need to email me at d. If you're trying to set up a one-on-one help, please email me at dpalacios at LAED Corps. Monday through Thursday, I can set up Zoom meetings with you guys from 11 to 12:30. I can also set up because I leave to another site, so I'm driving, so I won't be able to be available again until at least to uh, 3:30. And if you really need to, you can probably by the time the next time I'll be available is maybe around 4 to 5 p.m. And this is Monday through Thursday. Friday's a little tricky because of other commitments that I have, and it just depends. If you absolutely need for something to happen on a Friday, like a Zoom meeting on a Friday or a Saturday or Sunday due to special circumstances, email me and tell me about them so that we can set up what works best for you. I'm willing to help you out on the weekends if my time permits me, but we just have to find it. We just have to coordinate with a time that works for both of us. Okay. Um, if you, by the way, the link for the Zoom meeting is in the classroom. It's at the very top. Just click on it. But if you click on it and you don't make an appointment with me, chances are I'm not going to be on it. I'm not going to be monitoring. I might not hear you or see you, or you might be waiting in that wait room. Email me first is the easiest way. All right, guys. Good luck.